Hi, my name is Charlie. You can also call me the guitar boy. So today we are going to solve more examples on the topic calculations and the relationship between number of particles, mole, and molar mass. In our last class we did question one. We did question one. Today we are going to do question two. So under question two, we have sub questions under them. We have 1, 2, 3 questions under them. So we'll solve these 3 questions under this video. Without wasting time, if you have not watched that particular video, relative masses of chemical substances, the mole concept, go and watch those 2 videos. They are strongly related to this, and then watch the last video under questions under this particular topic. So we are going to solve the number one question now. Say, what is the mass of 3 mole of oxygen gas? Now I am going to try to make it very simple, but try to understand the chemistry behind the calculation so that you can calculate your question easily. Now it says, what is the mass of 3 mole of oxygen gas? Now I have to draw out the basic relationship between them. I know that 1 mole of oxygen molecule, like they said, they did not even measure molecule yet. They did not measure atom yet. Like I told you before, since they say gas, now imagine the oxygen gas you have in your atmosphere, you have in your laboratory. They never exist and they can never exist in free state. That they are stable state. They can never exist as an atom. They exist as molecule, that is O2. So when you hear molecule, just know this is, when you hear gas, they exist in their molecular form, except some that exist in atomic form. But oxygen, nitrogen, and some other gases exist in their molecular form in free state. So in free state, oxygen exists as a molecule, not as an atom. Meanwhile, so many of us will want to go and use this value. No, this value is not correct for you to use, because this is the mass of atom of oxygen. So you must multiply it by 2 for it to fit into this calculation. So what do we do now? We say 1 mole of oxygen molecule will give us 6.02 times 10 raised to power 23 oxygen molecules, and that is the number of particles. You remember from our previous video, number of particles, and also give us 32 gram of oxygen molecule. 32 gram of oxygen molecule. This is the mass of oxygen molecule, so it's 32. You know, the mass of atom of oxygen is 16. They gave you here, and they expect you, since they say gas here, to know that they are talking about molecule. They are not talking about an atom. So from there, what you now do is to say, do not check the one I told you in the previous video. You are going to draw 2 out, either these 2 or these 2 or these 2. You are going to draw 2 out of these 3 things we are discussing here. So you draw 1 out. Now, which one? How do we know the one we are drawing out? They say, what is the mass? Which means we are drawing mass out. Okay, what is the mass of 3 mole? We are also drawing mole out. So number of particle is not included in this relationship. So we are just going to say, draw these 2 out. You say 1 mole of oxygen molecule will give you 32 gram of oxygen molecule. Okay, therefore 3 mole, because they say what is the mass of 3 mole? 3 mole of oxygen molecule will give you S gram of oxygen molecule. You see how easy it is. Then when you cross, you now say S, this is what you are looking for. You write it out. S gram of oxygen molecule is equal to, you now use what you have here. You use what you have here to times this, divide it by what you have here. You now say 3 times 32 all over 1. So 3 times 32 all over 1, that's 96. That's 96 gram of oxygen molecule. So this is the answer to this particular question. 96 gram of oxygen molecule will give you 3 mole. 3 mole will give you 96 gram of oxygen molecule. That is the answer to this question. It is very simple. It is very, very simple. I tried my best to make it very simple like this. Let's move to the next question. Before then, let's clean this particular one. Now, this one is how many atoms? That is what? Number of particles. How many? You know particles, molecule, atoms, ion, all these are particles. So when you hear how many molecules, how many atoms, how many ion, how many neutron, how many proton, how many electron, so all these are particles. They are not the same thing as how many mole. Mole is used for, we use mole to measure these various particles. We use mole to measure these various particles. That is when we have just the same way we use dozen. Okay. Now they say how many, so you have to still draw the relationship. How many moles? We know that 1 mole of carbon atom will give us 6.02 times 10 raised to the power 23 atoms, because they said atoms. How many atoms? That's number of particles. Atoms of carbon will give us, this 1 mole will give us 12 grams of carbon. You know the relative mass of carbon is 12. Okay, and I told you relative mass and molar mass are the same thing. So what you have here, so this is the basic relationship between these three. So the first thing you should do is to draw out the basic relationship between the three of them. Now the next thing you should do is to know which one do you need as per the question given to you. Is it these two? Is it these two? Or is it these two that you need as per the question given to you? How do you know? You go back to the question. How many atoms, which means number of particles, you mark it out. That are there in 6 grams, that is mass, you mark it out. Okay, so since the relationship now will not be what between number of particles and mass, you proceed and say 6.02 times 10 raised to the power 23 atoms of carbon give us 12 grams of carbon. Give us 12 grams of carbon. This is the basic. You know this. I know this even before you bring this question. I know that whenever I have this, it will give me this gram. The relative mass will be what? 12, or the molar mass will be 12. I know this before now. So I will write what I know before I start attempting the question. However, how I will present it depends on the question. I will have to see the question first. That's how I present this. I know this one before now. You are not the one telling me. This question is not the one telling me. I know. Then I will now say, therefore 6 grams S atoms of carbon, that's this number of carbon, S atom of carbon, which I want to calculate, because they say how many atoms. S number of carbon will give us 6 grams of carbon. Then when you cross, you now say S atoms of carbon will now be equal to 6 times this, 6 times 6.02 times 10 raised to the power 23 all over 12. Okay, what you just do, when you do this, it will give you, that is when you say 6 times, you say 6 times 6.02 divided by 12. You do that, leave this one first. It will give you 3.01. It will give you 3.01. So you now add this one that you left before times 10 raised to the power what? 23. So this is the answer to this particular question. Can't you see how simple this one is? Says which means 3.01 times 10 raised to power 23 carbon particles, carbon atom will give you 6 grams of what? Carbon atom. So that is the answer to the number 2 question. Very, very simple. So we'll move now to the number 3 question. We move to number 3 question. Now, this number 3 question is also a simple question. It's also what? A simple question. Look at it. It says, how many moles? This one is not particles now. They are talking about mole. How many moles are there in 20 grams? This one is mass. 20 grams of calcium carbonate. This, look at the mass of the relative mass of calcium carbonate. This is the relative mass of calcium carbonate. So you come here, draw the relationship. You say 1 mole of calcium carbonate give us 6.02 times 10 raised to power 23. Just put particles. Give us 6.02 times 10 raised to power 23 particles. And this one will give us, look at the relative mass, you write 100 grams. 100 grams of calcium carbonate. So this is the basic relationship. You must know this first. How do you know that is 100 grams for 1 mole? 1 mole is the same thing as the relative mass of that substance or the molar mass of that substance. This is the number of the limestone or calcium carbonate you have in 100 grams of calcium carbonate. So you now have to choose if it these two you will draw out, or these two you will draw out, or these two you draw out. Let's check the question. Let us check the question. How many mole? So mole will come out. We will draw mole out. How many moles are there in 20 grams? So this one is the mass. 20 grams, which is the mass, will be used. We will leave this one. We will not use this guy here. So we now say if 1 mole of calcium carbonate give us 100 grams of calcium carbonate, therefore they said how many mole? S mole, because we want to calculate the mole now. We don't know. We want to calculate the mole. S mole of calcium carbonate will give us S mole of calcium carbonate will give us 20 grams of calcium carbonate. No, we want to know how many mole we have in 20 grams of calcium carbonate now. If then when you cross, you now say S mole of calcium carbonate is equal to this one times this one divided by what you have here. It will now be what? 1 times 20 all over 100. So the answer will now be, this one will now be what? 0.2 mole. 0.2 mole is our answer to this last question. As simple as, okay? So, like I tell you, you have to, like I always tell you, you have to practice. Mind you, your teachers practice, I practice. So you as a student, you need to practice, because practice brings about perfection. If you are here in Edo State and you are looking for physical classes where you have teachers from Fruitful Ground Tutorial, we are in Edo State, Saple Road Bypass or Kawan. We are very close to Belisima Junction. Do well to come and join us at Fruitful Ground Tutorial. God bless you. We'll meet in another video. Bye.